So folks, in this video, we're simply asked to determine whether or not the above system is homogeneous or non-homogeneous, and it is a homogeneous system. Let's actually look at, let's actually come up with this homogeneous system of equations. Well, the y bar prime is really just the vector y1 prime, y2 prime, y3 prime, where the bold vector y is just the unknown functions y1, y2, and y3. So let's go ahead and rewrite this system. So we'd have that y1 prime, y2 prime, y3 prime is equal to 2 minus 1, 0, 3, 5, 1, 1, 0, minus 2 times y1, y2, y3. If we write out the matrix multiplication on the right hand side, we'll end up with the vector 2y1 minus 1y2, and we will have 3y1 plus 5y2 plus y3, and y1 minus 2y3 for the third component. And so we can actually get back to the system of differential equations this way. Y1 prime of t is equal to 2y1 of t minus y2 of t. Y2 prime of t is equal to 3y1 of t plus 5y2 of t plus y3 of t. And y3 prime of t is equal to y1 of t minus 2 y3 of t, and we can see that all of these equations have only y prime terms involving y prime and y's derivative. So this is a, in this case, it is a third order linear system. Well, we'll add the word here in just a second. It's a third order system of ODEs. And what do we notice? Well, we notice that every term, so these are linear, and hopefully that makes sense that this is a linear equation. We're not raising any y's, unknown function y's to second powers or cubing them or taking the sign of them. Same thing with all the derivative terms. So it's linear, and so it makes sense to ask the question, is it homogeneous? And we can answer that by saying yes, it is homogeneous. How come? It's homogeneous because all of the terms, when written written term-wise, each term has either a derivative of y, of one of the unknown functions of y, or one of the unknown functions of y themselves, and there are no other terms in this expression, and so that's why this is a third-order linear homogeneous system. And that answers the question.